When a coyote bites a Texas horned lizard, the lizard shoots a jet of blood directly into the coyote's mouth. The coyote immediately drops it, starts opening and closing its jaws, drools heavily, wipes its muzzle in the grass, and spends the next 15 minutes unable to think about anything except getting that taste out of its mouth. The lizard walks away. This is not venom. The blood is the lizard's own circulating blood. The same blood running through every vein in its body at that exact moment. Something in it is so chemically repellent to canines and felines that a single mouthful is enough to end the attack and trigger what researchers describe as a sustained disgust response. Some coyotes have been observed pawing at their own faces and vomiting. The lizard can lose up to 7% of its total body mass in a single defensive squirt, and it can do it again repeatedly within the same encounter. Biologists have studied this for decades. The mechanism is understood, the chemistry is not. Somewhere in the blood of an animal the size of a human palm is a compound that functions like a biological weapon specifically calibrated for the mouths of wolves, coyotes, foxes, and domestic dogs. And science still cannot fully identify what it is. How it actually works, the Texas horned lizard has 2 rings of constricting muscle wrapped around the major veins that drain blood away from its head. Under normal conditions, these muscles stay relaxed and blood flows freely in both directions. When the lizard senses a canine or feline predator, it contracts both rings simultaneously, cutting off all venous drainage from the head while arterial blood continues pumping in. The blood has nowhere to go. Pressure builds inside a network of thin-walled spaces around the eye sockets called ocular sinuses. These sinuses swell visibly. The eyelids inflate, the eyes appear to bulge, until the pressure becomes so extreme that the sinus walls rupture. The blood then erupts through the corners of the eyes in a directed stream that can travel up to 5 feet. The lizard does not squirt randomly. It aims. It can control which eye fires and angle its head to direct the stream. Researchers testing the behavior noted that the lizard withholds the blood until the predator's mouth is within range, specifically because the chemical deterrent only works when it makes contact with the tissues inside the mouth. Blood landing on fur does nothing. Blood landing on the ground does nothing. For the defense to work, it has to reach the taste receptors, and the lizard appears to know this. The researchers who documented this behavior in a detail that says something remarkable about the discipline of science confirmed the mouth contact requirement by licking the blood themselves. Their assessment? Slightly acrid, unpleasant, but manageable. For a coyote, the same taste is apparently unbearable. Where the weapon comes from, the chemical that drives this reaction is almost certainly derived from the lizard's diet. Texas horned lizards eat harvester ants almost exclusively. Harvester ants are venomous, carrying compounds that most animals avoid entirely. The horned lizard eats thousands of them every day. It has evolved a chemical in its blood plasma that neutralizes the ant venom before it causes damage, and it produces thick mucus in its throat that immobilizes each ant as it is swallowed, preventing the ants from biting or stinging on the way down. What researchers suspect, and have not yet definitively proven, is that the deterrent compound in the lizard's blood is either a byproduct of this venom neutralization process or a concentrated derivative of the ant venom itself. Chemically transformed but still deeply unpleasant to mammals that share the same sensory receptors that harvester ants evolved to target. The horned lizard is, in effect, storing its food's most dangerous properties inside its own circulatory system and deploying them on demand. This would mean the lizard's diet and its defense are the same system. It eats the most dangerous ants in its environment, processes the venom into something it can tolerate, and carries the residue as a weapon in its blood. The rest of the arsenal, the blood, is the last resort. Before it gets there, the horned lizard works through a hierarchy of defenses that escalate progressively depending on the threat. The first line is invisibility. The lizard's body is almost perfectly flat. It presses itself against the desert floor, and its mottled, sand-colored skin makes it effectively disappear against the substrate. Most predators walk straight past without registering it. The horned lizard also produces no body odor, reducing the chemical signature that tracking predators rely on. If it is spotted and approached, the lizard inflates. Muscles along its sides pump air and fluid into its body cavity until it appears roughly twice its normal size, transforming from a flat, compact animal into a rounded, spiny obstacle that is suddenly difficult to swallow and even more difficult to grip. The spines along its back and the crown of true horns on its head, bony projections with a calcified core, not scale modifications, face outward and make biting down on the skull painful enough that most predators hesitate. If a predator manages to get the lizard's head into its mouth, despite the inflation and the horns, that is when the blood fires. The pressure on the head's touch receptors appears to be the final trigger. The lizard waits until the last possible moment, when it is already partially inside the predator's jaws, and fires the blood directly into the mouth at point-blank range. Snakes get none of this. The blood defense does not work on them, because snakes do not have the same taste receptor chemistry as canines and felines. Birds of prey also appear largely unaffected. The defense is specifically calibrated for the mammals that evolved alongside horned lizards in North American deserts, a level of evolutionary precision that implies a very long and specific predator-prey relationship between this lizard and the canid family, a defense that should not exist. The blood squirting mechanism poses a genuine evolutionary puzzle. Losing up to 7% of your body mass in blood is a significant physiological cost for a small desert animal in an environment where water and nutrients are scarce. A 2001 study measured squirts across multiple individuals and found that some lizards ejected as much as 6.8% of their body mass in a single event. The question evolutionary biologists ask is, why didn't simpler defenses suffice? The answer appears to be the coyote. Genetic analysis of the horned lizard family suggests that ocular blood squirting evolved and spread specifically in response to increasing predation pressure from canids. Species that no longer face significant coyote or fox predation have, in some cases, lost the ability entirely. The defense tracks the predator. It exists precisely because the predator exists, and disappears when the predator no longer needs to be counted. What makes this particularly striking is that the horned lizard appears to recognize the difference. Researchers who tried to study the blood squirting behavior found it nearly impossible to trigger by hand, by mechanical stimulation, or even by having a researcher get on all fours to paw and bark at the lizard. The lizard did not respond. It took a trained dog performing natural canine behavior to reliably trigger the blood ejection. The lizard is not simply reacting to threat. It is identifying the specific type of threat, selecting the appropriate tool from its defense hierarchy, and deploying it at the moment of maximum effectiveness. For something the size of a palm, and commonly mistaken for a toad, this is a remarkably precise and deliberate survival strategy. One that has kept the horned lizard alive in North American deserts for millions of years, shooting blood into the mouths of everything that tries to eat it. If this completely changed how you see what a small animal can do, subscribe and hit the bell. There's a new story every week. Drop a comment. Did you know the blood only works in the mouth? See you in the next one.